So let's have a look at the bar magnet first. Bar magnet is, we all know what a bar magnet is. How a bar magnet works is very complicated and actually is related to quantum physics. But we're not going to look quite at that. But basically, you can see the compass is attracted to this magnet because a compass is just another little magnet. The difference being is the magnet on a compass is a very light magnet and allowed to move freely. Now, electromagnet is a magnet that is made using electricity, and the reason for that is because whenever you have a wire with a current going through it, electric current going through it, it actually has a magnetic field. And if you put this so let's turn off these electrons to make it a bit less distracting. So if you put these wires in a coil, then it sort of amplifies the field. Now you can see here it's got a magnetic field because the compass is reacting to it. Okay, so it's getting attracted to it. But also the advantage about electric fields is I can control how powerful they are, and I can turn them off. You can't turn off. So this now does nothing, right? I can turn it off and I can change the power of it, or I can turn it around. So now it turns it around. So I can flip the pole of electric field. So if I look at the actual field, let's look at the field like this. This is how it's going to be shown now, and so I can change the strength of the field. It doesn't actually demonstrate it there. If I get a field meter and measure it here, we can see it says 44.51. If I reduce the voltage, the strength of the field goes down. And if I turn it the other way, well, okay, let's just look at the bottom, the BX. We won't worry about what they mean, but we'll just for now say it's magnetic field. Okay, if I reduce it, it goes down to 8.9. Now it's 0 because there's no voltage. Turn it the other way. Oops. Now it's negative because it's pointing the other way. So this is great. I can control this. You can't do this with a normal magnet. So if you had some sort of electrical device, like maybe you wanted to, like at scrap car yards, they pick up the car and they turn the magnet off and it lets go of the car, and they pick it up and then they turn the magnet back on again, pick up a new car. So they also use electromagnets in electronic door locks. So they use very powerful magnets that keep the door closed. And when you swipe your card, it turns off the electromagnet, and you can open the door then. So yeah, now you can control the strength of the electromagnet by obviously changing the voltage, like I said already. You can also change the number of loops on this coil here. So if I reduce it down to 3, the strength of the magnetic field reduces. And again down to 2, it reduces again, or 1. Now usually they'd have a lot more than 4 loops. They might have like a few hundred loops. But that is how to make an electromagnet. So it's a magnet that is made using electricity. The advantage is it can be turned off and on, or you can turn the poles around, and you can also change the strength. And the way to change the strength is by changing the voltage, which can be done with just a dial, so you can control the power. But you can actually design it to be a strong electromagnet by changing the number of coils. If you put an iron core in the middle of it, which basically just an iron block in the middle of it, that makes it even stronger as well. Okay, so that's electromagnets. Okay.